Okay, so now I'm out here with the fire extinguisher. Now that I showed how the storage tanks would work, I'll kind of show how you would do the next step. So you would have a tank similar to this fire extinguisher, and just unscrew it. So you unscrew the top. Once it's empty, I guess it's pretty much empty. Just discharged it a little bit ago. So you would have the capability of being able to open and enclose your tank that you're going to mix the two gases together in. And that way you can put this water inside the tank to provide a mixing substance of the two gases. So go ahead and take the hose here and give it some water. Probably wouldn't need too much, but just enough to be able to slosh around to ensure a good mixture of the gases. But since this is a fire extinguisher, I'll give it a little extra water. Okay. It sounds about half full, so we'll leave it there. So now I'll take the straw and the little cap here, put it back together. Alright. So this would be a tank that could hold hydrogen and oxygen for the power facility, the power station, but this one's just designed just to hold water and compressed air. So I'll just go ahead and give that a little twist tight there. Alright, there it is. Now it's on there all the way. So now so you can, now there's no pressure in there, but you can hear the water sloshing around with no pressure, and I can push the valve and nothing happens. But so if we take from the main tank inside, hooked up to the main tank here. Let's see. So I got my air chock here hooked up to the hose that is connected to the main tank, or that would be the storage collector tank. And then, oh no, this would be either the hydrogen or the oxygen tank now. You know, the main tank fills into the storage tanks like that one, and now we're going to be connecting these storage tanks up to a single tank and fill it kind of like so. So you can hear the thing bubbling down there on the inside. I'm not quite sure what's happening to the water. I wonder if the volume of the water inside is getting compressed into a smaller space with the pressure. But, look at the gauge on the side here. It's getting right into its main spot there. Can't really take any more pressure. So now that that's got pressure in it, it can now be, well first it would have to be mixed. So see, you can hear that the water's still sloshing around just like before, just like when there was no pressure in the tank. So even with pressure, it still sloshes around like if it was still at, just in the thermos, or if there was no pressure in it. But you would do that, you would have the water mix the two gases together, however long it takes, I guess, to make a certainty that the gas has been mixed. I'm not quite sure. I'm guessing it wouldn't take too long to mix them. And then you would control the discharge, like so, with the valve. And the gases would be coming out, a mixture of oxygen and hydrogen. Then all you would need to do is just ignite this somehow with a flame, and use the flame like a blowtorch or something like that to reuse the energy that you stored all day. There it is. That's how it would work. It would be some. I got this out because this would be some. I've filled these tanks before at one of my jobs, and the way they do it, it's a similar way. You have a big propane tank, a really big one that the truck comes and fills, and that one has a electric pump and a connector that goes onto here, and this is the valve that you would open up just like I did the air cub. And the way it works is you have a screwdriver that opens up this pressure release valve here as it fills, and once the tank is full, you'd start to see the gas, the liquid, start coming out here, and then you'd shut off the pump and close the valve, then close this, and then you would unscrew the attachment, and that's how you would fill a propane tank. So the propane tank pressures and the way the propane tanks are filled by gas stations or whatever you get the propane from it has the same transfer setup as what I'm talking about here with the hydrogen and oxygen gases, except you would be transferring the gas and not a liquid. And like this is a liquid under pressure, and the only liquid that you would have in there is water. And also I was looking at the sides of this thing, and the beautiful thing about doing the using hydrogen and oxygen is that hydrogen and oxygen gases are, even though they're explosive and highly flammable, they're not toxic like this. Propane is hazardous to your health. It's toxic. This is not healthy for people to breathe or be around. Now, hydrogen gas and oxygen gas are not, even though they're very explosive, just like this, very flammable, but this is toxic and this is not. Big difference. So anyway, those are my little examples on storage tanks, transferring the gases, and how the idea is sound and all the capabilities are there. You just got to build it and see if it works. The only part I don't know 100% if it would work or not is being able to capture the gases within the shafts during the electrolysis process. I would think you would probably need some sort of pressure reading inside the shaft or maybe some kind of visual thing down in the reservoir water area, just to make sure that bubbles are coming to the surface of your shaft from the electrodes. But that's the only part that I would, because if you pump the air too fast out the shafts, then you're basically just pumping the water up the shafts, and you don't want to do that. You want to pump the gases out of the shafts as they're rising to the surface. That way the pressure kind of stays equalized and you're not sucking water up the shaft, you're just sucking the air that's coming off of the electrodes. I'm pretty sure it will work. You just got to have a kind of a speed control capability for your air pumps that are pumping out of the shafts of the reservoir. You can't have them going full throttle. You got to be able to have some sort of a speed control or solid state control over those air pumps, so you can slow it down or speed it up based on your pressure readings. That's probably how I would do it.